Good morning, everyone. Thank you for joining us here today for this webinar on unlocking innovation with Creo Generative Design. Sorry, got caught up there. We're just gonna kind of wait just for a quick moment, maybe let a few more people trickle in. But we will try to leave enough time at the end for some Q&A. So please feel free to type your questions in chat or use the question feature, and we'll get to those in the order that were received, and we'll do our best to try to answer everything. Also, for those who are unable to attend, or if you want to share this with colleagues later, you will be able to get a copy of this webinar as soon as the broadcast ends. So, all right. So it looks like it's about 10:01. So with that, Thiago, take it away.
All right. Okay. So yeah, thank you, Nick. Good morning, everyone. Welcome to the webinar from TriStar. My name is Thiago Palaniappan. Like Nick mentioned, today's topic is going to be we'll be covering the Creo generative design extension and the topology optimization extension, a couple of new exciting extensions for doing some optimization on your design. So that's the goal. And before I begin, let me take a quick minute to introduce TriStar. TriStar is a company that helps manufacturing companies, adopt software systems and processes. The goal being to help them, enable and allow, more efficient and better product development. And we do that by being the largest value-added reseller worldwide for PTC, right? We do have our headquarters is in Phoenix, in Arizona, and we do have our team spread across the United States and Canada. I'm based out of a west suburb of Chicago, and we do have experience in windshield implementation, CAD, FEA, simulation, as well as some of our automation tools that we have for customers. So with that said, real quick here, just wanted to give you a quick overview on the agenda here as to the plan is to cover this in like 4 steps, if you will, wherein for some of you that may not be used to topology optimization overview, I want to do a very high level quick example at the beginning with a part as to how I would optimize it. And then we'll get into the differences between GTO versus GDX. One is, the topology optimization, generative topology optimization extension. The other is a generative design extension. What is the difference there? One is cloud-based, one runs locally in your machine. We'll also go through the setup from scratch. It uses multi-body techniques. And so we'll go through that. And towards the end, if time permits, we'll also go through some of the recent enhancements that was done all the way from Creo 7 through Creo 11. With Creo 12 should be out in a week or two, I'm thinking. But and towards the end, like Nick mentioned, we'll go do have a Q&A session. If you could start typing in your questions in the chat or the questions area, I'll try my best to answer it before we wrap up. Okay. So with that, let's move on to the next slide here. So the idea is to go over at a very high level to show you how you could give a set of objectives or constraints. It could be manufacturing constraints, it could be design constraints. You give almost like a sandbox or like a solution space for your geometry, and then you're trying to use maybe a safety factor, or maybe you're using a volume or a mass percentage as a goal. And then you're trying to also use the AI engine that Frustum has. PTC acquired a company called Frustum back in 2018, and that's the engine that's working inside behind the scenes for this optimization. So many of us, whenever we think about optimization or topology optimization, which has been in the industry for a long time, we always think about, okay, it's mainly for printing, right? Is it mainly only if I'm going to 3D print my design, it could be useful, but not exactly. You could specify the manufacturing requirements, right? Maybe I want to cast this, I want to mill it, right? Or maybe I want to print it. So depending on your manufacturing constraints, the system is going to give you the geometry, which you could use as a starting point. You don't have to just use that, but that's a good starting point as engineers, designers. I've been there in the industry myself from 1996, where I've used various tools, and then we are more used to the traditional optimization where you're telling the software that, okay, I want the von Mises stress to be less than this, or my deflection should be less than a specific value, but here are my dimensions, here's my radius, here's my thickness, right? That's the traditional optimization where we were using specific dimensions and then using the software to crunch its numbers when we change those dimensions. This is slightly different, wherein we are kind of giving it a volume and then applying having it say, okay, I want to reduce the volume by 30% or 50% or 70%. I'm giving a goal as a percentage of the original volume, and then having the software give me some geometry depending on the constraints that I've applied here, right? So you can see an example here. It's the steering stem of a motorcycle assembly is what I have here. So before we take a deeper dive, maybe I want to jump into Creo real quick and kind of show you at a very high level how this would work, right? It's something that's already set up. I'll also go through a setup from scratch in a little bit, but at this point, I do have, let's say I have an assembly that we use in our demos quite a lot. It's one of the PTC demo data set I use for my demos. But maybe this part right here that you're seeing for the steering subassembly here, I already removed some weight off of it, as you can see. But maybe I want to try to use this generative topology optimization to kind of reduce some weight on it at the same time, make it stronger, and let's see how the process might look like. And I know when I activate this part right here, you could see the current geometry, the constraints, from a loading perspective. We probably have to do a structural analysis, wherein we know some load conditions here is probably constrained in here. And also we might be looking at different materials, different manufacturing processes, etc. Right? So what I could do is maybe I already have a model for this, and we'll just go switch to a different model here, right? I got a model, and that has already been set up a little bit, but we'll also go through the setup from scratch with different examples here. But multi-body is being used for this, right? It's a prerequisite for using the topology optimization. So if you look at my design items here, I got two bodies here, the envelope and the preserved body, right? So if I look at the envelope, that's like your starting geometry, if you will, right? If I can isolate that, I'm giving the system, this geometry in here, and I'm also saying some of this geometry I need to be preserved, right? It needs to be preserved, and I don't want you to do anything on that area or on that volume. So I have another body here called preserved body. So essentially, I'm telling it, can you just give me this area, this volume that I'm kind of sketching around here? This is the area I want some help with to give me, as to, maybe I might ask it to reduce the weight or, come up with a geometry that you think based on my constraints, right? Using the AI engine that Frustum has behind the scenes under Creo, right? So it is an extension. It's an add-on extension, obviously. But so right now, let me just go reset the status here. I hit a few. So it is using multi-bodies, right? Some of you may know Creo 7, we introduced multi-body, or PTC introduced multi-body, and that's what we'll be using today, right? So first off, I'm going to go into my applications and going to generative design. So just like your simulate and other applications, you have generative design. So I go to generative design, and it looks very familiar UI. You can do multiple studies. For now, they support structural and modal. In Creo 12, you'll also have thermal that's coming out later this month. And then you define your design spaces, right? Your starting geometry, preserved, excluded geometry, also your physics, right? And then you start defining your criteria. This is where the main thing lies, right? That's where you define your geometry constraints as well as manufacturing constraints. And then you pretty much view the results, and you can also create, the design using PTC has it automated using the subdivisional surface modeling that Freestyle has, right, built in. And if you want, you can even send it to the cloud. You can upload it to the cloud and then do multiple design criteria and multiple, materials, multiple loads, constraints, different options where you don't have to run it locally. You can just upload it to the cloud and then get it back into Creo. So that's the high level overview. But in this case, right now, I want to just tell the software that, hey, that's going to be my starting geometry, right? I also want to tell this is going to be my preserved geometry, right? So it turns that preserved geometry into blue. And then I'm also going to apply some constraints. I showed you the assembly. It's part of the steering subassembly in my motorcycle assembly. So I'm going to go fully constrain this guy here. And I also want to apply some loads here. So, and let's see if I could, maybe I'll apply it in a specific unit system that you're familiar with, pound, force, Newton, what have you, right? That you would see in most simulation tools, you have that. So let's say I want to assign about a specific value, and the X and Y, some known values is what I'm typing in here. That might be part of another mechanism analysis you may have done, and you kind of know at the intersection at that geometry, that's the load that's happening, and that's kind of what you're assigning here, right? And then also you can also assign material and additional criteria. So for now, it still tells me that it's not yet ready. I don't have any criteria, design criteria, right? Right now I have given it the solution space or a starting geometry, preserved geometry. I could give an exclude geometry, areas that I'll show you with the different examples where I could create some obstacles to the existing solution space if required, but that's optional. And then when I go into my criteria, I should be able to give two types of criteria. Being a structural analysis, I could maximize stiffness, essentially minimizing strain energy, right? And limiting the mass or the volume, right? I'm giving it a target volume as a percentage, or I could specify a specific value for that too, right? A couple of ways to do that. Or I could go minimize mass and based on safety factor. This was kind of introduced in Creo 9. There are a few enhancements they did over the years, but there are a couple options there. So when I go back to maximize stiffness, maybe I want to tell it, okay, 70%. So, the original volume, right? And then my target is 70% of the original one. That's what I'm giving it. I'm asking it to maximize the stiffness. In other words, increasing the strain energy essentially, and adding constraints. There are different types of constraints. We'll talk more about it. For now, I'm not going to apply any constraints. Depending on am I going to mill this or cast it, or it's going to be 3D printed, I could specify a few different constraints and few geometry constraints. For now, I'm going to kind of leave it blank there. As for materials, I could go use optimize based on different materials. Maybe I want to go assign, let's see, if I could go to, maybe we'll pick up the new library from PTC. They introduced in Creo 4.0, so we'll just use this material, and we'll just activate that material, and there you go, right? So I could do an initial simulation and kind of check the results of the initial simulation right there, right? That is the original one before the optimization. That is a way to look at it, right? I can look at, maybe I'm interested in megapascal, the maximum 1 stress, right, or the deflection, right in there. You can look at that, and including the safety factor. If the yield strength of the material is assigned as part of the material property, you could do that. But now that everything is defined, how do I know? It tells me the study is fully defined here, and I should be able to just hit the optimize right now, and it's running. It's an asynchronous operation. While it's running, I can continue with my work and do other work as I'm doing this. But if you notice, since I didn't give any specific manufacturing constraint, you could see how it's starting to connect those geometry surfaces where I had asked for that 70% goal on my volume percent of the original volume that we had. And it looks like it's a simple design. Obviously, it took about very very short time there, and it ran pretty quick there. And what I can do now is maybe I could look at the results here. So it is doing that. It's just a rough one, right? You can also do a high fidelity FEA using Creo Simulation Live or Creo Simulate, but right now it's using Frustum's own built-in FEA solvers right there, right? I can look at the stresses. I could look at where are the max stresses, etc. Right? I also have a little probe that I can take a look at. Now, as for comparing, right, I should be able to also go compare the two, right? Before the optimization and after the optimization, I can take a look at that. I could animate it, right, with deformation, etc. But maybe I'm not I'm not interested to print this, right? I would rather use the traditional casting or milling manufacturing process. That's what I'm interested in. So in that case, what happens, or before we do that different scenario or a different criteria for my manufacturing process, can I just create or generate a design? Yeah, you can generate a design right here. You can either upload it to the cloud and have it work with the different variations you've given, or you can generate it in here. Now you could go generate either as a tessellated geometry, maybe you want to create your own geometry just by using the tessellated geometry as a visual reference. That might be a one option, or you can do a reconstruct. So when I do a reconstruct, I'm kind of using PTC subdivisional based surface modeling techniques here, where I can get to provide the resolution of it. I'll just use the default resolution here, and I'm going to generate it, and I'm going to call it, okay, this is going to be, it's going to, in my workspace or working folder, depending on I'm connected to Windchill or not here, I could just say, okay, this is going to be the 3D printed one is what I want, and it creates a new part out of this, and it's warning me that, hey, there's a different material that you had. We changed it, remember, from steel to an aluminum alloy, I believe, and so now we're going to get into that's what it warned me about, and it is creating the geometry as we speak at this time, right? What it's doing is it's going to use those the geometry created first, and it's going to convert that into curves at the attached surfaces, like freestyle curves, and then it's also going to create a surface mesh out of it. It's almost there. Um, there you go, right? It's the last step. It's finalized the design here as we speak. And there you go, right? So if you see, this is another model, right? There's a completely different design here. However, it has all the features. It has the GDF feature that tells us that it's using generative design feature. I'm able to go and edit the study. And it has a reconstruction that's kind of already done here, right? It has merged it also, right? It certified it has created the freestyle surface, as you can see here, right? And that can be modified if required, and we'll get into more later on this. But now this is great, but like I said, I may not be 3D printing it, and what if I wanted to have use a different manufacturing process? I should just be able to go back to my original start design that I'd used, and I can go back to my design criteria, for example, and add a manufacturing constraint, right? So I should be able to go and add, for example, I'm going to go do a linear extrude, right? So maybe we want to go mill this and going to provide the direction of the tool for milling, right? So that's kind of what I'm telling it here. I'm giving the surface here. I could give an angle if required, make it bidirectional or not, depending on am I going to do on one side the 3-axis milling, or is it 2-axis? Depending on that, I could have it bidirectional or not, right? There are different constraints you can give, and you can add to this, make it symmetric, etc. And I can continue right now. Right now, it's a fresh new design criteria that I've given, and I could say I want to maybe try optimizing this, and it's going to take a little bit of time for this one too. And I do have a completed one that I can quickly open, but just to give you an idea, depending on the manufacturing process that you specify, you could see how it is no longer going to be creating those the structure that it connected more for an additive manufacturing. This one, it understands it's going to be extruded, and the geometry it's creating is a lot more kind of what I might do. And you see how it's trying to connect these, and I can let it run, or I could kind of pause it, right? So maybe I'm going to pause this for now. There's a process manager here that I can, it's an asynchronous process that you can see that I'm able to resume, cancel at any time, and open the study. But I do have let's see if I could open up a model where this is already created with that same criteria, with the extruded manufacturing constraint. This is the design here, and I could use it as a starting point, right? I could obviously go and create my own extrudes and ribs and what have you, but the idea is you got this other alternate design that you have to work with, that you can work with. compared to the initial one. And so there could be several variations like these with different materials, different load conditions, etc. Right? Or I could just go, I should be able to go and even create an interchange assembly where I could use my different variants. It's interchange assembly is essentially a bucket for all your variants, right? That some of you may have used. And here I have an interchange assembly wherein if I look at my the original weight compared to I have a parameter for the weight, and you can see how we are kind of optimizing it or reducing the weight. At the same time, we have these different manufacturing process driven designs that we have here. And maybe I can go back to my assembly, and I should also be I should be able to go and replace the component, just do an interchange, part of an interchange assembly. So I should be able to replace with interchange assembly and select that additive model, take a look at it, right? This is the one that we chose to go with. And there you go, right? So it does have that reference, to the original one, but we can generate multiple parts off of that. And just a quick example to show you, for those who have never seen it, I thought I should do a quick overview before we talk about how to define this from scratch, etc. Getting back to my presentation here, with that little high-level overview, just to talk a little bit of history here about optimization in CAD in general, right? Both in simulation and design. Many of you that have used old Pro Engineer or Creo Parametric currently for a long time, you probably already know that within the old Mechanica or Creo Simulate, there was optimization studies, right? Where I could tell the deflection shouldn't exceed this. The stress shouldn't exceed this. The temperature in my printed circuit board shouldn't exceed this. And you can give minimum, maximum, like a solution space, but it's all dimension driven, right? And there's also a behavioral modeler extension that kind of allows you to do design optimization where you are able to create some analysis features, some outputs, maybe the CG location, what have you. It is all, very much metrics driven there, unlike topology optimization where you are allowing the AI engine working behind the scenes. It used to be the company Vanderplast R&D. That's what PTC used to use back in Creo 5 and 6, right? For the topology optimization, they're no longer using that, right? There used to be their partner back in Creo 5 and 6 of, I hope all of you are Creo 7 and above by now. But then if any of you are still using Creo 5 or 6, you still have to use that VR&D technology. But starting Creo 7 with the acquisition of Frustum, the AI company that PTC acquired back in 2018, they were able to use the Frustum AI engine. And based on that, they have these two extensions called Generative Topology Optimization, GTO, and Generative Design Extension, GDX, which is cloud-based, where instead of doing it locally in my machine, I want to set up all the criteria and all the different load cases and material options, and then I want to just upload it to the cloud and have it do all the heavy lifting, right? So that's also possible. I'll demonstrate both in the next half hour or so, but so prerequisite is you do need Creo 7, right? For using what I'm demoing today, you have to be at least on Creo 7020 or above, right? I'm using Creo 11, but you need at least Creo 7 to do this. So with that overview or with that high level example, you're asked, okay, what exactly is GTO? And if you think about it, like as I've listed here, it's just a way to apply manufacturing constraints and design constraints and geometry constraints. It could be for structural, it could be for modal, it could be also for frequency, right? Though that was introduced recently in Creo 9 and 10. And then thermal will be introduced in Creo 12. But the goal is, as you can see at the bottom image right here, I'm giving it a solution space. The transparent areas of volume, I'm giving a starting geometry. I'm kind of blocking it with my red excluded body here. I have the blue bodies where I want you to preserve those, but so I don't want you to be changing those areas. And then you see how with my constraints, it's kind of able to build that geometry for me, that what you see on the top, on the right side, depending on the constraints that I've given, right? Whether it's going to be a cast, if it's casting, maybe I give a parting line. Is it a 3D parting line or a 2D parting line? And I can give the angle, etc., right? So depending on that, it is going to generate a geometry for you, which is kind of very different from many of us when we do think about optimization. We're always thinking about minimum, maximum dimensions, and then give me the best possible dimension when where you want to keep it lightweight at the same time stronger. This one is you're giving it a target volume, right? So multi-bodies is very important to use in here, right? And of course, you could, if required, if you say, hey, there are so many scenarios that I would like to analyze, but I don't want to waste my time, my computer's local resources to keep running it. Can I just upload it to the cloud? And that was introduced in 7020, where you are able to look at the scatter plot of the different variations. Like, in this case, you can see, is it going to be 3D? Is it going to be cast, for example, or is it going to be 3D printed, or is it going to be milled? Depending on that, you have so many variations with different materials, and you're able to review that. And I'll show that also in some time from now, where I'll show you how to upload and how we can leverage that for some heavy lifting with several other different design variations. And the ones that you like, you can get it back into Creo, right? That's kind of very useful too. So the real difference between GTO and GDX, if you think about it, is GTO, or generative topology optimization, runs locally on your machine. It does require a license, right? And Creo 7 and above uses that Frustum technology that I was talking about. And then GDX, a prerequisite to use GDX or to upload to the cloud is you have to have GTO, which is essentially creating that initial setup in Creo, right? And then having the Frustum solvers in the cloud, in PTC's cloud, run the different options for you. And then you can even disconnect and you can just upload it and then go review the study. And then they have some, you can interrogate the results and get the best possible design that you want and get it back into Creo, right? That's the process. So that's the difference between GTO versus GDX. And maybe the idea is to set it up, run the optimization, do the reconstruction, and also review the results. And then, if required, as an optional step, you could also upload it and get those different, different criterias, analyzed and optimized in the cloud, right? So that's the other option there. Now, for those who are new, or some of you may have already used this, some of you are pretty new, and how do you set it up from scratch? What does it take to set it up, right? The setup process here, right? That might be new to many of you, and so maybe I want to walk you through that a little bit with an example where nothing is being set up, literally nothing. And if we just have a design, and how do you set it up? And the first thing is obviously the design space, right? So you want to make sure that you control, or at least you look at the you have to have some multi bodies there. Each body should be designated as a starting geometry, as a preserved geometry, or as an excluded geometry, right? So you have that. The reason we kind of encourage you to do that is just to make sure that when you read the final geometry, you do want to preserve, for example, that slot and the area around it. You might be using it to apply some loads and constraints. And you may want to use as a block. I mean, this could practically be built into the original space, or you could use multi-body for it. Just to give you a quick example as to how I might want to do that from scratch, let me just get out of some of these files that I have. And if I open, let's see here, I'll open up a design right here. So this is just a simple design with a single body. As you know, starting Creo 7, every part that you design in Creo, it'll be all the features will contribute to a single body, right? There's body one, right? That's it, right? Nothing, no other bodies at this point. What I can do is I should be able to add new extrudes. For example, I probably want a volume around this geometry to be preserved. So how do I tell the software that? I can just go do a new extrude, have pretty straightforward, right? I would go project. With Creo 9, they changed the ability to quickly do that, the new option to shift select it, right? I've created that loop. I probably want to do a quick offset off of this as well, right? So maybe I want to do a quick offset in there, and maybe I want to go extrude this guy all the way, like a shift, holding shift and snapping up to. I don't want to remove material, but I want to create a new body out of this, right? So when you do extrudes and starting Creo 7, you have the ability to specify to which body it's contributing to, right? There it is. So that's a new body in there. So now I got my second body, which will be activated. But similarly, I can just go add, let's see here, we can add a couple more real quick here. We'll just say we want to go, we'll just use it as a reference, and we'll just say we want to go with a different diameter here, and we'll just say I want to go snap up there, and then maybe create another new body in there, right? And similarly, just one more to go here. So I have three bodies that will be used as preserved bodies, essentially, right? That's what I'm going to do here, and maybe I'll just use it as a reference. And we'll just go specify some known dimensions here. What it takes to set up from scratch. It's always good it's great to see when everything's already set up, but what it takes to set it up and everything, right? That's what I'm showing you here. And if I go create a new body, and there it is. So we got 4 bodies at this point, body 1, 2, 3, 4, right? So if I go select these 3 bodies and isolate, you get the idea, right? I'm essentially telling these are my preserved volumes, if you will, right? And let me go reset the status here. And then what I'm going to do is I'm also going to go specify like maybe a couple of shafts here or pins where I want to apply a load. So you could also create like additional, for example, maybe I want to do another extrude here real quick. We'll just use the same one. And maybe we want to go maybe in a second direction here. We'll just set it to a specific, some known value. So it comes out of that body. That's pretty much it. And I want to create a new body out of this, right? And I also want to go add another one here where we will just go and let's do a quick circle out of this. It takes a moment to get that snap, isn't it? And then if I go, we'll just go make it into the second set as well. And we'll say I want to go, let's see, there it is, right? So, and do another new body out of this. So we got 6, we are kind of rapidly adding multiple bodies, as you can see. We can rename them, etc., if required, but you get the idea. So one other body that I could potentially do maybe is add, maybe I know that could have been part of the original design, but maybe it's almost like I want you to work around this area. I don't want anything to happen in that area. It's kind of like an exclude area, right, that I want. What I could do is I could go, let's see if I could sketch, maybe we'll just do, we'll go to references and we'll grab this as a reference for now. And maybe for some quick sketching here, it's a good practice to use Sketcher Palette, as many of you may know already, but that can be customized. And there are some good enhancements that's coming up in Creo 12 and this with additional racetrack shapes. But so if I go and we'll just leave it something like that, I'm happy with that shape for now. Maybe we'll just go do we'll just do a quick trim on all of this real quick, and there it goes, right? And maybe we add a couple dimensions just to control this, and maybe we want to go from here to here, right? We'll just specify some constraints that I might be interested in. I already have that, so we'll also make it go horizontal in here. Maybe we want to also add a radius dimension and kind of get rid of this. Right there, and looks like, yeah, okay. So with this, maybe I want to make sure that it's kind of working around it. Maybe we'll just specify some symmetry constraint about this also, maybe off of these two. You no longer need a center line for symmetry constraint. There's a cool enhancement in Creo 7 that some of you might like. But again, let's say I want to go with a specific dimension here. We'll just set it to some value here. We'll just make it a little larger here. And that's good enough for me, right? So let's say, yeah, that's pretty much what I want. And I probably wanted to go have it extrude up here. And we'll probably say on the side too, maybe I want to go have this up to this face right here. And what I'm able to do is create this as a new body, of course, right? So that is going to be a new body. And so if I go and go to my, getting back to, I have a shortcut for the generative design here. I can get back my right mouse click. I have most of the options here that I've customized. You can do that. And in my generative design, I should be able to go set this as a starting geometry. As soon as it says a starting geometry, the system makes it transparent, letting me know that is a solution space given, right? That's the original volume that it's supposed to work within, right? And then I'm also going to go select these guys that we did, right? These three loads that we are, or I'm sorry, the bodies that we had. I'm going to make that as a preserved geometry, and that will turn it to blue, and maybe make this guy as an excluded geometry. So with this, I have kind of defined my design space, which is kind of like a prerequisite for running this. You know, you could run it without an excluded geometry, but of course, and also you could also run it without starting geometry. There's a recent enhancement where you could just have those blue bodies, and it'll automatically figure out the preserved geometry. That's a way. There was a way to do that too. But now I should be able to start adding some loads in here. So maybe I want to go apply some forces. You know, maybe I have my triad going in the x direction. So let's say I want to go about 5,000 Newton in this direction here. I probably can set it to direction magnitude there, and turn on my constraints and loads in there. The same thing, I want to go apply a force load on the x direction, but this time it's going to be negative here. We'll give it a few newtons in that direction. Maybe on now this is one load case. I could have multiple load cases too, right? So I could go and fix this. Maybe I want to fix all these surfaces right there, right there. And the nice thing is you do have a troubleshooter that's telling you there's something wrong going on here. So if I kind of cursor over it, it kind of tells me that, hey, you have tried to apply a load that's not connected to the solution or the starting geometry. So it's kind of encouraging me to apply a contact between that undesignated body. Remember, we never designated this gray pins or shafts that I have here. So what I could do is I could add a contact between this and this, right? There it goes. That error goes away. Same thing when I add a contact between this guy and this guy here, and the error goes away. So with this one, I should now be able to at least add the secret sauce is really this design criteria, right, that you're doing, where that's where you're going to tell it, okay, I want to maximize stiffness and limit volume. My target volume is 30% of the original volume. And then I want to add constraints here, and maybe I want to make it symmetry, right? And I want to select, for example, one of these datum planes here that I might have as my symmetric constraint. I'm going to use this particular alloy as a material, and I should just be able to just hit the optimize. And what it's doing right now is based on those constraints, and you can see it's starting that with that initial volume, and it has worked around that red volume that I had specified, or the body, right, the excluded body. If I hadn't had that, it might try to connect it here. And so I know we could have included that in the original design space, but just to show you, you could add multiple bodies. And that is looks like it was pretty quick, where it has already created the optimized study here. It kind of gives me 31%, the mesh used, etc., and everything here. I can obviously go to this body and kind of hide that red body out of there. And this is where the next step comes in, right? So we talked about how we are using solution space, and there's additional options available, which I didn't go over. I mean, you could control the design criteria depending on, are you trying to manufacture using casting and forging methods, or do you want to specify the build direction for 3D printing, where you can assign even the critical angle, which is kind of the maximum angle, with respect to the print direction at which supports are not needed. That would be the build direction option, for example. Or it could be a simple linear extrude, where you are using it for 2-axis and 3-axis milling methods, right? So the constraint kind of creates this linear extrude. Essentially is creating a linear pull direction, which is the direction of the tool used for milling, right? You could either make it bidirectional. A bidirectional extrude is flat on both sides, or you could say, okay, I want to have it one direction, where it is free form for a 3-axis milling machine on one side, right? So all that could be provided, including geometry constraints, right? So for example, I may want to control the symmetry like I did in this case, where I want to make it symmetric. It could be rotational symmetry, it could be planar symmetry. Both are supported. You can even control the minimum feature size, right? It kind of controls the feature size and the optimized shape, right? You're essentially controlling the thickness of the resulting model in a way, right? And the minimum crease radius could also be provided to smooth out solid geometry and kind of reduce the number of webs you might get sometimes, right? And also control the material spreading, right? You can give it a value, right? Increasing the value of the material spreading will kind of get you like lesser thick and solid regions, for example. So it's really got to play around with these different options to get the best options there, or you can upload it to the cloud and have it, solve that for you, right? A couple of options there. So all these is based on the Frustum patented technology that PTC is talking about. That's the engine, the true solid engine that's kind of working behind the scenes, right? And then finally, you can view the results. And we talked about how we can interrogate the results and also create that B-rep geometry, right? That's very important. Where in many optimization tools, right, they give you this geometry, but what next, right? You don't want to reverse engineer this manually, but you want to go generate design and you want to go create a new part, and then you give it, what level of resolution you prefer, and then maybe you are creating that. We'll just create a new one here, and it is generating with multiple steps, all those in pretty quick time. You can see that's quite a lot of surface geometry there, and it is pretty quick. I have about 32 gig of RAM. If you have GPU, it's not required, but if you have GPU, it could take that for the solving too. But let me kind of hide this guy here. But you see that it has generated this, and if you want, you can make changes to those, and it really has a reconstruction geometry inside, right? So there's one option, but I can always go back and say, okay, so maybe I want to go back to my criteria and redefine the criteria and say, okay, that's great. I was able to make it symmetric, but now I'm going to use, I don't know, I'm going to cast it, for example. I need to have so I'm going to go to the parting line, and you get to control the pulling direction here, right? So I can go control, there's my pulling direction. I can give it draft angle of 3 degrees right here, right? It could be 2D or 3D. 3D means it'll figure out its parting line depending on the angle I give and the geometry and the direction. And when I do that, you could see that, it is, if I go back to my criteria here and redefine it, if I give like maybe we'll give it to the top datum plane or something here and draft angle about 3 degrees, and I could do 2D or I could do 3D. And as soon as I start optimizing it, if you watch closely, maybe I'll hide my constraints and everything, to these preserved geometry there, right? You could see that immediately. You could see that little angle, 3-degree angle right in there, right? And it's starting to now think of it as a casting rather than something that would be using additive manufacturing here. So just added that 3-degree angle, and you will see even in the freestyle curve, it'll have the draft angle 3 degrees in there. So it's pretty neat that it's able to use the manufacturing process combined with your design constraint to give you this geometry there, right? So, and this is where I could go with that additional options, right? Minimum crease size and things like that to kind of reduce these additional geometries, which could be high stress concentration regions or difficult for manufacturing. You can use it as a starting point, right? That's the idea, right? The time it would take for you to do this yourself versus kind of using the AI engine behind to do this for you is the benefit here, I think. And so I could just go generate a design off of this one, and I could say, hey, I could even make it tessellated or reconstructed, and I can go with this and generate multiple ones like this. Maybe I'm thinking, no, you want to go, instead of this, I probably don't want the design to be a casting. It's going to be milled. So I'm going to go add a constraint where I'll just do a linear extrude, right? And I'm going to specify linear extrude. I could make it bidirectional. Bidirectional means both the top and the bottom will remain flat. If I uncheck that, it's going to have a free form on one side where I may be using a 3-axis, machining in there. So if I go and do a little optimize on this guy now, so each time you can see just a few examples of how, depending on that objective and the constraints that you're giving, it's really nice that now it's starting to create those ribs, and that you would do. I'm going to machine this, and the reason I did the bidirectional is so that I get that flat surface on both sides. If I had said one direction, maybe here I might have gotten a free form geometry. And I'm not saying you have to use this, right? Exactly. You could possibly just have something like this done and then go and just build some geometry around it. You might want to do your own sketching around it, but at least you have a good starting point. Is a key here, right? Where I don't have to have it generate the model itself. I could just create a tessellated model. That's an option too. I could go tessellated and generate the tessellated model real quick and use that tessellated model, which is like a faceted model right here. And I could say, hey, you know what? I could probably go and do a sketch and everything, something like this. And I can start using it as a visual reference to kind of build around it. You see where I'm going with this, right? So whenever we talk about topology optimization, there is a perception with most designers that, hey, it's only for designs that's going to be 3D printed, but not exactly is my point here with these demos, right? It could be used for multiple manufacturing processes and methods, right? It creates that feature that's associated to. You can make changes to your design, redefine the model, and you can do that. And finally, having seen a little bit of how the GTO setup works, now how would we upload it to the cloud, right? How does that look like, right? The idea is to first set it up in GTO instead of Creo Parametric, and then send it to the cloud where it's using those multiple frustum solvers for you, and it gives you the ability to interrogate the design and view the results and compare the results, etc. Right? So, the way that is done is maybe I could let me see if I could open up an example where that might be a useful one to kind of show you here. Let's see if I could open up a model. Let's see if I could open up, yeah, this one here. If I go to, I have an assembly that I use in many of my large assembly management demos. It's a Laser Z lawnmower, one of PTC's customers. They allow us to kind of showcase that for top-down design. And so I got an assembly that's kind of loading up as we speak here. And maybe a component in this assembly, I'd like to, let's see if I could go to one of these lift on the right. Yeah, right. Let's say I had a subassembly. Yeah, that's the one I was looking for actually. But this component right here is kind of what I want to optimize. And let's say I want to get into this part here, where as you can see, again, I have my preserved bodies right in here. And if I go to generative design here, unlike the previous examples, I already have quite a few criteria already set up. So I have one for milled, cast, additive 1, additive 2. So each one having their own criteria, right? And it could even be multiple different materials, right? For example, if I go to my additive 2, right now it says limit volume by 63%, or that's the target volume there, and then linear extrude, the parting line, and maybe I want to go and add another material, right? So maybe I want to go and let's see if I want to go with a ferrous metal here. We'll just go use stainless steel for it. So these are so I can activate each one and run it one by one, but I don't have the time to do that. As a designer or as the engineer, I'm giving it the criteria. I'm defining the criteria, and after this, I just want to send it to the cloud right here, right? I mean, good practice to test it once that you've done everything and you're not running into errors about the number of iterations and the setup, etc. But then after that, you can just go send it to the cloud, right? So, and it'll kind of warn you, right, about it's a PTC hosted cloud system and about the security and all that, right? So, and once you say okay to that, it's going to ask you to log in with your ptc.com account, and depending on the number of credits and your licensing that you have for that, let me just go and see if I can log in here real quick. And it's using the embedded browser. It's kind of uploading my study, my setup, and everything at this point of time. You can see at the bottom right there. I've already run this and everything, but I'll kind of show you how that does too. So if this was a kind of a new structural study, right, I could say create, and I'm uploading the study at this point. And I won't be fully be waiting for it. I already have one that I've in the cloud and I have it run, but you could see how it pretty much captures your entire setup, right? All your setup including that new material. Remember the stainless steel that I had added there during my setup. So this could be used even to update existing designs. And I'm able to kind of select all my criteria. I pretty much want all criteria. So it could be different analysis types, different physics, different loads, constraints, materials. And depending on the number of credits, right, it looks like you need credits to do that, but I hit generate. And it is now I can just, you know, get back to my regular engineering work, and over the cloud is what the computation is happening. As you can see, right, it is going through those different 12 designs. That is the combinations based on my iterations that I've given and the materials. It's working on that, right? So let it kind of run there, and we'll come back to it in a little bit. But I can always go back to my generative design here, and I could look at the by study, and there are a few other things that I'd already done, right? A few of these files that I already done right in here. So if you see and open one of those studies, it has those are the ones that I've already created. And if you see 12 designs are there, right? And really easy to see what's happening here, right? You have like a filter option with a parallel coordinate plot. That's pretty nice with Mach deflection, safety factor, mass, and volume, right? And you also have a scatter plot where you could say, look at safety factor, or look at the mass, or maybe you want to look at max deflection in here. And you can also have a grid view. So grid view is essentially kind of showing you all those different 12 options with different criteria, and it has the results for each one, right? The safety factor, the mass, etc. So, and I can also go select a specific one in there, and it'll kind of highlight it for me and open it and integrate it, or I can interrogate it individually, or I could do a little compare, right? And maybe I want to select, maybe we'll select this, the additive, we'll pick this guy here. We'll also pick the cast. We'll also pick maybe they allow up to 3 things that you can compare, and then I should be able to go compare those. And as I'm comparing them, I can look at the von Mises stress, the displacement magnitude, which are there, the scaling factor for the animation, etc. Right? So that's an option. You can go back to your design or setup, and you can kind of filter it, right? So maybe I want to filter by only the casting here, right, that we did, or maybe I want to go by material and say I want to go alloy. These two are the only 2 ones, and all these you can kind of drag them around, and so the safety factor, for example, here I could also kind of say, show me all the designs that I'm just doing a drag within these vertical graphs plots. It's kind of highlighting only those, or I could also drag them to another location. So it's pretty, very easy to use to look at the variation that it has created for you. And maybe I liked one of them, right? This is the one I liked and I preferred, and I can just send it right back to Creo, right? And it is, it's like having it do all the heavy lifting in the cloud. It's almost like batch processing it if you think about it, right? That's the AI engine. When we keep saying AI, these words, in my opinion, AI is used sometimes too much everywhere these days. What is a true AI benefit here is the Frustum solver engine that's AI based, right? And instead of doing it locally in your machine, you are able to kind of run it over the cloud. And this is what you would, this is the one that it came back to Creo, and I'm planning to use it. And that is my design that I could use, and I can replace my assembly, etc. Right. So that's the idea behind using, the GDX is kind of what I demoed in this last few minutes here. You can also share, collaborate. I know we're running out of time here, but there are options to. It's based on PTC's Onshape Atlas cloud platform, right? So that is the one working behind the scenes. So you are able to, look at, share it, send a link, and your admins will be able to create permissions, provided they have credits and licenses for that, for those who can view it. So with that, I know we are, maybe I want to get to some Q&A if possible. So really quickly here, even though this was introduced in 7.0, starting 7.020 is when they introduced the GDX, or the cloud-based extension, and they've been improving it since then, right? So if you see really quickly at some of these examples, I may want to have an automatic envelope without defining the envelope. Can the software figure out the envelope? And that's possible, right? Maybe I want to specify the crease radius to decrease those number of webs that I get in between in there, right? Those things are all kind of new enhancements over the years that PTC has been adding. So it is an extension that's continuing to develop a lot. So if I look at automatic starting geometry here. So I do have just I don't have an envelope, right? No envelope is done here. I didn't create that envelope. I just have my preserved geometry. Can I go to generative design and maybe I'll kind of remove my preserved geometry real quick here so you can see what's going on. I'll remove everything right here. And if I were to set this up from scratch, of course, yeah, I can set up these guys as all preserved geometry, right? As soon as I do that, right, watch what happens if I go remove some of them. As I keep adding additional preserved geometry, you could see a volume being created here. So that's pretty nice where the software knows to kind of create maybe I want to not leave that guy there, obviously, right? Well, the software knows to create that rough volume. Now, the only caveat here is when you add your design criteria for this automatic starting volume, as you can see, they have removed the percentage, which makes sense because the software doesn't know the original percentage of the volume. It's like a rough one, so you can only specify the actual value in pound mass or kilograms or what have you, right? So that's important to note. But there are, quite a lot of improvements like these where those are already using it. Just a quick snapshot. I know we are kind of running out of time here, but we do have the option to do modal, where I could say minimum frequency, or I could say minimize the mass, and these are the frequency that I want. You can apply design goals based on structural or modal. Thermal is coming up only in Creo 12, right? And also additional things like rotational symmetry. That's awesome, right? Where instead of giving a planar symmetry, you're also able to give rotational symmetry and do idealizations like in regular FEA, where I have an object here where I do know the CG location. I don't really care about that. Can I apply a load there as a mass element, apply an acceleration 1g to it, and then distribute that load? We do that in simulation quite a lot, but it's nice that there's more and more things are being added to this with each release. And finally, in Creo 11, the ability to remove these, because it looks cool in a demo, these things, but in the real world, you probably don't want these, right? So that's when you can control the minimum feature size, where you could say it should be 3 times the minimum element size, and it will kind of help you give you a better, better structure than the one that you have there, right? So maybe I can wrap up the demo with that and see some questions for sure here. I'm sure that also you have a lot of questions. I've been talking fast and doing a lot of demos here just to maximize the time. I thought of including as much information as possible. But so if I had not actually, let me go back to this one here. If I had not specified that minimum feature size, this is probably what I'm going to get, right? So if you look at my design study here, and if I go edit the study here, you can see my bodies here that I've used, right? So there's an envelope, there's a keep out, there's a pin, etc., right? That's how we got this going. But what about this? If you look at my criteria, right? I just said, symmetry, planar symmetry is all I cared about, and I specified a material, and that's it, right? But what I could do, I could go add another constraint and say, I want to go with minimum feature size. And what is a rule of thumb? What should we be using here, right? If you see the size, that's your element size 8. You have to be at least about more than 3 times that, right? That's a rule of thumb. So it's 8 times 3, 24. Maybe I'll give it roughly 30 or 35. And then I hit, and if I say okay, and it's obviously a new one in there, and if I hit optimize, maybe I can, while we see it work on it, maybe Nick, are there any questions?
Yeah,
While
let's see. No questions have come in, but we
Yeah,
have about a minute left on time here. So yeah, if
sure.
anybody has any questions, feel free to type them in the chat. And if we don't get any, we'll go ahead and wrap up this webinar. Thank you, Thiago, for everything. Awesome as always, very knowledgeable.
All right. Yeah. Thanks, everyone. Yep.
All right. Yeah, looks like
No
no
questions, right?
questions. Jeremy says thank you. Thank you,
All
Jeremy. We appreciate that.
right. Okay. Yeah. No problem. Yeah, if you have any
Okay.
questions, please reach out to us. I mean, the webinar, like Nick mentioned, I'm sure you'll all be getting a recording, but there are webinar recordings available on our website and also in the TriStar YouTube. We do have all our colleagues, in different areas. We do put together a lot of these webinars that you should be able to watch there as well. But yeah, if you have any questions, feel free to contact us at tristar.com. But yeah, thanks everyone, and have a great rest of your week.
Thank you, everybody.